I'm Dr. K.Budhraja from Shri Venkateshwar College, University of Delhi. Over here, we are going to have a series of lectures on theory of games. Now, what exactly is a game? Many among us must have played so many games since our childhood. To name few, comes to our mind is cricket, another one is badminton, and in cards we play solitaire, bluff, sweep, etc. So, we have these games over here with us. So the first one is cricket, and now later on, in the initial we played the game of cricket in the form of a 5-day test match. Later on, all these have been simplified and modified, and we started playing one day international matches. In the beginning, it used to be 5-day test match, and thereafter we had T20 tournaments also. In badminton, we had singles. Thereafter, it's again being modified into doubles, mixed doubles, etc. And in cards, we had solitaire, sweep, and bluff. Now, each of these games over here, they have different rules. So what exactly is a game? Is a set of rules which the players obey. While playing it. So, what exactly is the game? Is a set of rules which the players, needless to say that a player is one who plays the game. Then we have n-person game. A game in which n players play is called an n-person game. Say, for example, in cricket, all these games over here, these are two-person games. Although in each team we have 11 players, but it's treated as two-person game because collective efforts of the whole team is counted at the end of the game. So cricket is a two-person game. In badminton also, singles, doubles and mixed doubles are two-person games. In cards, solitaire is a one-person game. A sweep can be 2 to 4 person game, whereas the bluff can be any number of person games. 5, 6, 4, I mean any number of persons can play with a bunch of cards of first in the bluff. Now next is play of a game. Now what do you mean by play of a game? A game played once is called a play of game. Now suppose I'm playing solitaire 3 times. This means that I'm playing 3 plays of the solitaire. Suppose India and Pakistan are playing 3 one-day international matches. And we'll say that it's India and Pakistan are playing 3 plays of the one-day international match. And then the question is, why do we play games? Now, the question arises that why do we play games? And the answer to this question is, sometimes we play the games for time pass, sometimes for fun, entertainment, and quite a number of times for money. Most of them, we see that the money is involved in the games. Not only we take a lot of interest in playing the game. Our next aspect is what do you mean by zero-sum game? Zero-sum game is a game in which one player wins and the other player loses. Suppose I am playing 5 times, this means that I am having 5 plays of the one-day international matches. Suppose India and Pakistan are playing 3 one-day international matches. What do you mean by zero-sum game? Zero-sum game is a game in which one player wins and the other player loses. Suppose I am playing 5 times, this means that I am having 5 plays of the one-day international matches. Suppose India and Pakistan are playing 3 one-day international matches. What do you mean by zero-sum game? consider a play of an n-person game with players P1, P2, Pn. Let Pi be the payment made to the player Pi. Now, if sigma Pi is equal to 0, then we call the play as a zero-sum play. Then we call the play as a zero-sum play. Finally, if every possible play of the game is a zero-sum play, then the game itself is called zero-sum game. So in this way we define a zero-sum game. Now Pi may be positive and Pi may be negative, where sum is going to be equal to 0. But in case one of the Pi is negative, it means that that particular player Pi is going to pay the money. Say if some player P2 gets minus 5 units, it means that P2 will pay 5 rupees. Now we have the following some results about the zero-sum games. Number one is that almost all the games are zero-sum games. Another is that in zero-sum games, the money is neither created nor destroyed. It's being shifted, it's being transferred from one person to another person. Now in our study, we have to deal with a particular type of two-person zero-sum games. We call these games as rectangular games. Now what exactly is a rectangular game? Before coming to its definition, we'll have an example over here. Now suppose there are two players here, P1 and P2. Now what P1 has to do is to choose a number from a list of some numbers, say 1, 2, 3, and then P2, without knowing what the choice P1 has made, will choose a number from 1, 2, 3, 4. Now the two numbers will be then compared, and P2 will pay to P1 according to the following rules. And the rules is like this one. This row is for, these numbers are for P1 and these numbers are for P2. So it's 2 units here, minus 3 here, 4 here, minus 1 here, 0 units here, 4 here, 3 here, 2 here, 1 here, 3 here, minus 3 here, and 2 here. Now it's like this. P1 will choose a number from 1, 2, 3, and P2 will choose a number from 1, 2, 3, 4, and then P2 will pay to P1 in accordance with this table here, this matrix over here. Now, suppose P1 chooses number 2 and P2 chooses number 3. Then 3 is the sum, is the number of units which P2 will pay to P1. There is only precise convention that we have fixed it, that P2 will pay to P1 in all rectangular games. So if P1 chooses number 3 and P2 chooses number 3, then minus 3 units are to be paid to P1 by P2. This means that P1 will get minus 3. It means P1 will pay to P2 3 units over here. Now such games are referred to as rectangular games. Now the question arises that which number P1 should choose so that he should get the maximum, and which number P2 should choose so that he has to pay the minimum. Over here in rectangular games, remember one thing. We are neither player P1 nor player P2. We are a mathematician who has to tell that what is the best choice for P1 Now what is the best choice for P2? In order that P1 should get the maximum and P2 should pay the minimum. And here we have the definition of the rectangular game. Now consider a two-person game with pairs P1 and P2. Suppose that P1 chooses a number from I equal to 1, 2 up to n, and P2, without knowing the choice of P1, chooses a number from j equal to 1 to n. The two numbers are then compared and P2 pays to P1 according to pre-specified matrix. Now such games are referred to as rectangular games. Now this pre-specified matrix is called the payoff matrix of the game. Now solving a rectangular game means to find the best choice for P1, the best choice for P2, and the amount which P2 has to pay to P1, called the value of the game. So let's begin with one example over here, in which we'll show that how to proceed for the value of the game for a rectangular matrix. Now consider a 3 cross 4 rectangular game whose payoff matrix is this one. Now look at that. If P1 chooses number 1, then P1 can get 7 units if P2 plays number 1, minus 3 units if P2 plays number 2, 6 units if P2 plays number 3, and 2 units if P2 plays number 4. Now whatever P2 plays, if P1 plays number 1, then P1 is sure to get the minimum of all these. That is, he is sure to get minus 3 rupees. Similarly, if P1 plays number 2, then he can get either minus 2, 4, 3 and minus 1 respectively. And then he is sure to get minus 2 units over here. Similarly, if P1 plays number 3, then he is sure to get minimum of 0, 4, 6 and minus 5. That is, he is sure to get minus 5 units. This means that P1 has a choice so that he can get the maximum of these minimum. That is minus 2 units. So there is a choice for P1, that is number 2, so that he can get the max of these minima. Now on the other hand, if P2 plays with number 1, then he has to pay at the most 7 units if P1 plays number 1, minus 2 units if P1 plays number 2, 0 units if P1 plays number 3. So at most he has to pay 7 units, whatever be the choice of P1 is. Now similarly, if P2 plays number 2, then he has to pay at most the maximum of all these ones. That is 4 units. And if P2 plays number 3, then he has to pay either 6 or 3 or 6. So at most it comes out to be 6 units. And then likewise, if he plays number 4, then he has to pay 2 units, minus 1 units or minus 5 units. That means at the most he has to pay 2 units. Now looking at these numbers here, this means that there is a choice so that P2 has to pay the minimum of all these maximum. That is, he has to pay 2 units over here. Now again, the problem of P1 is to get the money, so he would like to maximize his earning, and P2 has to pay. Consider an M cross N rectangular game with payoff matrix Aij. With P1 as a player, he has to choose numbers from 1 to M, and P2 has to choose numbers from 1 to N. And just to distinguish between the numbers, we have put the numbers for P1 in the circles, whereas for P2 in the squares. Now, to suppose that P1 chooses number 1, then if P2 chooses number 1, P1 will get this sum. If number 2, it's A12. If number N, it's A1N. In any case, P1 is going to get minimum of A1J if he plays number 1. Similarly, if P1 plays number 2, then he is sure to get minimum of A to G over G. And likewise, if P1 plays number M, whatever P2 plays, P1 is sure to get minimum of AMG. Now this means that P1 can get this sum, can get this sum, can get this sum. It means that he has a choice so that he can get the maximum of all these min over here. So that P1 can get max of these min. Now likewise, for P2, if P2 plays number 1, then P2 has to pay either A11 or A21 or AM1. It means that he has to pay at the most maximum of AI1, maximum of I. Now if P2 plays number 2, whatever the choice of P1 be, he has to pay at the most maximum of AI2. Similarly, if P2 plays number N, then he has to pay at most maximum of AIN. Now P2 has to pay at most either this sum or this sum or this sum. This means that there is a choice for P2, so that P2 has to pay the minimum of all these ones. That is, he has to pay minimum of these maxima that is this sum. Now let's summarize. There is a choice for P1 so that P1 can get this sum, max min. Now on the other hand, P2 has a choice so that he has to pay at most this one. He has to pay this one. Now our intuition says that definitely this quantity is going to be less than or equal to this much, which precisely is the case. That is, max min Aij is always less than or equal to min max Aij. Now before proceeding further to the rectangular games, let's compute max min and min max for some of the matrices. Let's find max min and min max for this matrix over here. What exactly is max min? Is equal to max of min A1j, min A2j, min A3j. That is equal to max of min of A11, A12, A13, min of A21, A22, A23, and just substituting the values, we get this as 1, 3, 6, 2, 3, 1, 3, row wise is 6, 2, 1, and then the minimum over here is 1, 1, and 1 respectively. Their max will be equal to 1. No, this 1 has come from here, and this one is from here, and this one is A11. So let me write this as A11 over here. This one is also from here, as well as from here. So it's equal to A22 and A33. And min max is equal to min of max AI1, max AI2, and max AI3. And this will be this expression over here. And it will be min of max of this, substituting the values, you will get here 1, 2, 6, 3, 1, 2, and max of 6, 3, 1, which is equal to min of 6 over here, 3 over here, and max over here is 6. So 6, 3 is 6. Its minimum will be 3, which is because of this element, and this element is A1, 2. So this is min max. Observe that max min is less than or equal to min max. Our max min was 1, whereas min max is equal to 3. So we have here that max min is less than min max. Next, we are going to give a shortcut to find max min and min max for the matrices. We have here a shortcut method to find max min and min max for any matrix. For example, let's take the same matrix which we did earlier. So this is our matrix over here. What we people do over here is we compute the minimum among the elements for each row. So this minimum over here is 1. This next minimum is in the next row is 1 again, and next again over here is 1. And then we take the maximum for all these ones. So max min will be equal to maximum of these ones, 1, 1, 1, which is equal to 1. And likewise, we find maximum in the columns is 6 here and 2 here, 3 here, sorry, and 6 here. And then min max will be equal to minimum of these maxima, that is 6, 3 and 6, which is equal to 3. So in this way we can compute max min and min max straight away from the matrix only. Another way is, what we do, we encircle the minimum of each row like this and put the maximum of each column in the squares like this, and then maximum of all these circled elements is max min and minimum of all these squared elements is min max. Again observe that max min is always less than or equal to min max. Now next we are going to give you some exercises in which you need to compute max min and min max. Now try your hand on these following problems. Just find max min and min max for these matrices. This is the first one, this is the second one and third one. And observe that max min is always less than or equal to min max in all these cases. Consider the rectangular game with pair of matrix as this one. Now here we find that max min is like this. Minimum is -3, is 2 here, of this row is 1, and then max min will be equal to max of -3, 2 and 1, which is equal to 2, and say this element is A22. Here maxima is, maximum of the first column is 6, of the second column is 5, the third column is 7, sorry, and then min max Aij is equal to minimum of 6, 5, 7, that is equal to 5 is A12. Now observe that max min is less than min max. Now this means that there is a choice for P1 so that he can get this 2 units. Now on the other hand, there is a choice for P2 so that P2 has to pay 5 units. We have max min less than is less than 5, which is min max. Now this is the amount which P1 can get. There is a choice for P1 so that he can get this sum. There is a choice for P2 so that P2 has to pay at most 5 rupees. This means that P1 can get 2 and P1 can be restricted to get more than 5 units. He can never get more than 5 units. So anyway, since P1 would like to maximize her earning, so he would like to reach up to this sum. He would like that. He has a choice. P1 has a choice so that he can get 2 units. But simultaneously there is a choice for P2 so that P2 has to pay 5 units. So P1 can think of achieving 5. And similarly, P2 would like to think about paying only 2 units to P1. So P1 would like to reach up to this sum and P2 would like to reach up to this sum. Now what happens if the two are equal? Now in case the two are equal, then is here max min Aij is equal to min max Aij. Now suppose for some game it's like this, 4 units here and 4 units over here is 4 units. The two are equal. This means that there is a choice for P1 so that P1 can get 4 units. And there is a choice for P2 so that P2 has to pay at most 4 units. This means that for both the players, 4 is the optimal value of the game. Is the value of the game. 4 is the amount on which both the players should settle themselves. Now let's generalize this one. In an M cross n rectangle game, we have max min is always less than or equal to min max. Yeah. What these entities mean to the players is this, that there is a choice for P1 so that P1 can get this money, this sum, and there is a choice for P2, so that P2 has to pay this sum. We have this quantity less than equal to this quantity. It's because of mathematically. Then P1 can get this sum and P2 can restrict P1 to get more than this sum. Isn't that? Because P1 would like to maximize his earnings, he would like to reach up to this sum. Likewise, P2 would like to reach up to this sum. P2 would like to pay this sum. P1 would like to get this sum. Now, when this can be possible? We need to check whether max min is less than or equal to min max or not. Now, suppose for some I and j, the two are equal, that max min is equal to min max. That is, here it is. We have for some I and j's, max min is equal to min max. Then P1 is going to get this sum, which is same as this one, and P2 has to pay this sum. So for both the players P1 and P2, we have the optimal choices I and j, for which max min is equal to min max. So in case this is the case, then our problem is over. That we need to find those i's and j's for which max min is equal to min max. And for this, let's define one saddle point and have some results. We consider an m-cross-n rectangular game with pair of matrix Aij, where I belongs to I and j belongs to capital J. Now, a point I0 J0 in I cross J is a saddle point of Aij. If Aij0 is less than or equal to Ai0 J0 for all I in I, and Ai0 J0 is less than or equal to Ai0 J for all J in J. This means that I0 J0 is a saddle point of Aij if Aij0 is the maximum value in the column J0, as well as is a minimum value in the row I0. Now, when does a matrix possesses a saddle point? We have a necessary and sufficient condition for a matrix to have a saddle point is like this. We consider an m cross n rectangular game with pair of matrix Aij, where I belongs to I and j belongs to j. Then a necessary and sufficient condition for max min to be equal to min max is that the matrix Aij possesses a saddle point. Further, if I0 J0 is a saddle point of the game of the matrix, then max min Aij is equal to min max Aij is equal to Ai0 J0. And this is the result which we just had talked about. Is the necessary and sufficient condition for max min to be equal to min max or the matrix to have a saddle point. It's both ways. We have the matrix here, which is 3 cross 3 matrix. So 3 numbers are there for P1 and 3 numbers are there for P2. What is the best choice for P1? As well as what is the best choice for P2? And then what is the amount P2 has to pay to P1 will be the value of the game. Let's find out max min over here. Minimum among the rows. In the first row is 3. In the second row it's minus 3. In the third row it's 1. So max min will be equal to maximum of these 3 elements, 3, minus 3 and 1, which is equal to 3. And then let's find out min max. Maximum for the columns is 5, is 3, is 4, and then min max is equal to minimum of 5, 3 and 4, which is equal to 3. And now look at this. This 3 comes from this 3, this 3 is this one, and this 3 has come from here, and so this is equal to A12. Likewise, this 3 has come from this 3 is this 3, and this 3 is this one, so it's equal to A12. So we have here max min Aij is equal to min max Aij is equal to A12. Therefore, this game has a saddle point 1, 2. That is, the best choice for P1 is number 1, and for P2 is number 2. And this A12 equal to 3 units is the value of the game. So write this as B equal to 3 is the value of the game. So optimal choice for P1 is number 1, optimal choice for P2 is number 2, and 3 is the value of the game. Let's have a shortcut to find max min and min max and to find the saddle point for the game. It's like this. Encircle the minimum of each row. Is here 3, is here -3, is here 1. And now put the maximum of each column in the spheres. Is 5, is 3 here, is 4 here. Now, here you have both circle as well as a sphere. That point, corresponding point will be a saddle point of the game. So over here, this 3 is the value of the game. This point, that is 1 and 2. 1, 2 will be the saddle point of the game. Choice for P1 is number 1 and choice for P2 is number 3. Now, so far in our study, we've been doing those problems where a saddle point exists. Now we'll take up in the next lectures where there's no saddle point. That is when max min is not equal to min max. Then what to do in such problems? We'll discuss that in the coming lectures. Further, over here, let's try some of the questions over here, exercises and examples for our child. Now let's solve this game here. This is pure matrix is 2 cross 3 matrix over here. Let's find out max min and min max over here. In a shortcut way, say minimum in the first row is 2. Just encircle that. Minimum in the second row is 0. Then maximum in the first column is 2. Maximum in the second column is 7. Maximum in the third column is 3. From the matrix itself, we can find that we have a circle and a sphere on this element. So this element is the value of the game, and corresponding INGs are the best strategies for best choices for P1 and P2. So over here, B equal to 2 is the value of the game. And optimal choice for P1 is number 1 and optimal choice for P2 is again number 1. Now B equal to 2 is the value of the game. Optimal choice for P1 is number 1 and optimal choice for P2 is number 1 again. Let's solve the game over here with pure matrices, as this is the first one, this is the second, third, fourth and fifth one. Over here, you'll find that there are multiple saddle points over here. See, let me solve this one over here in a shortcut way. Circle the minima, it's like this, and circle the minima, it's like this here. Put the spheres for the maximum element, and wherever you have a circle and a sphere, that is a saddle point. So we have over here in this game 2 saddle points, 1, 1 and 1, 2. So the value of the game will be same here, is 2. Optimal choice for P1 is 1, whereas optimal choices for P2 are either 1 or 2. You can play number 1 or number 2. So 2 will be the value of the game. Likewise, to solve all these other problems. Before concluding, let's discuss this problem over here. It determines the range of values of P and Q, which will render 2, 2, a saddle point of the game. 4, P2, Q5, 7, 10, 3, 9. And over here, in order to solve this one, we should make use of the definition of the saddle point only. We know very well the point 2, 2 will be a saddle point if, look at this, AI2 is less than or equal to A22 for all I varies from 1 to 3. Well, there are 3 nodes, so I will take the values from 1 to 3, and A22 further is less than or equal to A2j for all j varies from 1 to 3. Again, 3 columns are there. So the point 2, 2 will be a saddle point if AI2 is less than or equal to A22 for all I varies from 1 to 3, and A22 is less than or equal to A2j for all j varies from 1 to 3. We have 3 i's over here, 3 numbers for P1 as well as 3 numbers for P2. That is, if A12 is less than or equal to A22. What is A22? Is 5 over here. So we'll write here that A12 should be less than or equal to 5, A22 should be less than or equal to 5, A32 should be less than or equal to 5. Now look at that. This means that A12 is P, should be less than or equal to 5, A22 is 5, 5 is less than or equal to 5 is true, and A32 is 3, 3 less than or equal to 5. So this means that is if P is less than or equal to 5, 5 is less than or equal to 5, and 3 is less than or equal to 5. Look at this holds this holds. So we must have P should be less than or equal to 5. And here it is, A22, that is 5 should be less than or equal to A21, 5 should be less than or equal to A22, 5 should be less than or equal to A23. That is, here it is, 5 should be less than or equal to A21. A21 is our Q. 5 should be less than or equal to 5, and 5 should be less than or equal to 7. Look at this. These two are true. So it will be a saddle point if Q is greater than or equal to 5. So this condition we require. Hence, the range of the values of P and Q for which 2, 2 will be a saddle point is that P should be less than or equal to 5 and Q should be greater than or equal to 5. We have another question of the same type. I'll just write the question and then you try your hand on this question. Now, try your hand on this question. It's of the same type as we did the earlier one. Determine the range of values of P and Q that will render, that will make 2, 2 a saddle point of the game this one. Just make use of the definition to get the answer. We do have another method that we make use of the necessary and sufficient condition. You can find max min and min max, it should be equal to A22, but that is little bit difficult, it's a tedious job. So better is to make use of definition in order to solve such questions. Thank you.